Hi, my name is Drew Anderson. I'm a research specialist here at the Basket Wildlife Research and Education Center at the University of Missouri. We're interested in studying the movement of water through soils and plants, and how changes in water supply can affect the water status and the functioning of the forest. This video provides a brief introduction into how we measure leaf water potential using the pressure chamber technique. So to understand water movement and plant stress, the most important measurement is something that we call water potential. And there are many different components that add together to give the total water potential, and we focus on that total water potential. You can think of water potential as being a measurement of the energy density of water. So much like the flow of heat is related to a difference in temperature, the movement of water is controlled in part by a difference in the water potential. And the leaf water potential, especially when measured before dawn, can serve as a good indicator of plant stress. Today we're going to go over how we collect leaf samples and analyze them for water potential using the pressure chamber. But before we go out, we have a quick equipment checklist to go over. First, we have a plastic bag with a damp paper towel inside. We have a cooler with an ice pack. We have a razor blade, and then when we head out before dawn, we also need flashlights as well. Here we are at our sample tree. So to collect our sample, first we're going to use a razor blade to carefully cut the leaf petiole, ensuring that the cut is clean and both perpendicular to the length of the petiole. We store the leaf in a sealed Ziploc bag with a moist paper towel on ice until analysis, and that analysis takes place within 1 hour of sample collection. This is the pressure chamber that we use to measure the water potential of our leaf samples. This one was custom built, but you can buy them commercially. So the main components are the chamber, where the leaf sample is placed and then sealed with a lid. The lid, where we actually affix the leaf. There's a three-way valve that allows nitrogen gas to pressurize the chamber, it vents the chamber, or closes off the flow of gas altogether. And the nitrogen is held in these bottles over here to the side. There's a needle valve that provides fine control for the rate of gas flow into the chamber, and we have a pressure gauge to let us know how much gas is actually filling the chamber. We also have this microscope and light to increase the accuracy of the measurements. We determine water potential by pressurizing the chamber and measuring the pressure that is required to force water back out of the leaf petiole. When we see the first appearance of the wetting front darken the petiole cross-section, we've reached our endpoint and we record the corresponding pressure. Water potential is reported as a negative number, so we slap on a negative sign and then we're good to go. So to make our measurement, we first place the petiole of the leaf through this rubber stopper using a special insertion tool. The stopper is then installed into the recess of the lid, and the stopper ensures a complete seal so that no gas can escape during the measurement. We take our three-way switch and place it in the charge position, and we're now ready to start slowly letting gas into the chamber with the needle valve. To make a good measurement, we need to go slowly, about 10 psi every few seconds, to ensure that we don't overshoot our endpoint. And as we're increasing pressure in the chamber, we're going to look back and forth between the microscope and the pressure gauge. And once we see the wetting front, we quickly note the pressure and record it on a data sheet. Once the measurement is complete, we close the needle valve and turn the three-way switch to vent the chamber. Hopefully you now know how we measure leaf water potential, but before we go, I'll summarize a few key points really quick. Water potential is a measurement of the energy density of water. Water movement through the soils and plants is driven by differences in water potential, and pre-dawn leaf water potential is a useful way of measuring relative plant stress. Thanks very much.